So this is that region that we need. They first tell you that my region R is enclosed between two curves. What are these two curves respectively? The equation on the left here is what we have gone through. This is your ellipse. The one on the right, x squared plus y squared is 7. This is giving you a circle. You have got a circle, you have got an ellipse. Can we find the exact shaded region R? So a few things that we don't have yet. I don't even have the coordinates at the intersection points. You need those coordinates before you can even do any integration. So I do some working here first. Can we intersect both curves? I want to find the intersection points manually. Okay, so let me make y squared the subject. I'm going to substitute to the ellipse equation. I intersect directly here. So x squared over 4 plus your y squared. Can I move this x squared to the right? So I will get 7 minus x squared over 16 is 1. I'm intersecting the two equations directly. To simplify, can I multiply 16 throughout to get rid of the denominator? Sorry, right side 16, my bad. Okay, so let's shift. So 3x squared equals to 9. X squared equals to 3. So my x is plus or minus square root 3. Okay, so why is there an x with plus and minus? It's because you have got two values. This is negative root 3. This is positive root 3. Okay, but with that same value, let's find the y. I want to get the coordinate. So substitute x is plus minus root 3 to your circle equation. Okay, let's use the easier of the two. I go for the circle. Okay, so plus minus root 3 square plus y square will be 7. So your y will be plus minus 2. Okay, let's put those values onto my diagram. So basically this particular coordinate at the intersection is root 3, 2. My other points will be similar, but I'm only going to use the top right quadrant to find area. The goal later to get the area of the shaded region is, can we use this yellow color region and we multiply by 4, since it's going to look like a symmetrical diagram. Yeah, just find this yellow area, then we multiply by 4 throughout. Okay, so that is the objective. Let me use the two diagrams below to talk about the different strategies. I rewrite this point in. This is my root 3, 2. We focus on this region. Let's integrate with respect to x-axis. Okay, so if I'm just looking at this particular part, this is clearly bounded by two different curves. So we aim first, split up the region. This is the extreme left point. I check that the limit there is 0. The extreme right point, my limit is root 3. I usually check for the extreme left and right first. So in between, there is no other intersection points, meaning we will go for this as your top curve or your upper curve. I will be subtracting away here, which is the bottom curve. Take top minus bottom. Okay, but again, slightly complicated. If I want the top curve came from the ellipse, I will need to make y the subject from your ellipse equation. Okay, so we have to do it slowly. Okay, so y squared over 16 is 1 minus x squared over 4. We make y the subject. y will then be plus and minus square root. If you're integrating with x-axis, you need to make y the subject. So same for that bottom curve, but it's easier because this is a circle equation. I make y squared the subject first. So y will be plus minus square root. Okay, therefore, for this equation, let's start writing in the area. Area will be 4 times. Remember, I'm using one particular region and we multiply by 4. So we take 4, integrate 0 to root 3. Take the top minus the bottom curve. So top minus bottom, top, remember both are positive is the top half. So you will choose y to be the positive value. So top is square root 16 minus 4x squared, the one in red. And I subtract away the bottom part of the curve. We multiply by 4. Okay, so the idea here is we go for top minus bottom since it's between two curves. But the question sometimes may force you to go with respect to the y-axis. So I want to illustrate again, but it's a different technique altogether. Then again, we calculate this area, but let's do with reference to the y-axis. If you're going to do with respect to the y-axis, the first thing I always do is, can you check what is the lowest possible to the highest possible limit? This will help you frame your limits when you integrate later. Okay, so at this intersection point, the y value was 2. What is the highest position in the ellipse? So for the ellipse equation, what is the height of the ellipse? Height of the ellipse can be viewed as this part is y squared over 4 squared. So the height is actually at 4. This vertical height from the center is 4. So from 2 to 4, how are we going to find this particular area? You then check for this particular region, does your curves touch the y-axis? Your curve does touch the y-axis again here at this position. Your circle, what is the radius? If I know the radius, I can check this y value. So radius is square root of this number on the right-hand side, which means at this position, I will get square root of 7. So what is the idea here? If you're going to do with respect to y-axis, what will you get when you integrate this red curve? Integrating the red curve with the y-axis will give you this particular shape. You always get area with respect to the axis. Okay, so you will get that. We want to subtract away the blank spaces here below. So this part of the graph, we will want to get this. We subtract and take red minus the green. Okay, so go for red curve, subtract the green color curve. If we do with respect to y-axis, you got to remind yourself, when I start the equation later, it starts with integrate x dy. So unfortunately for the prep work, you got to make x the subject. Okay, so let me start with the ellipse again. We want to make sure we get x being the subject. Multiply by 4. So x we will get plus minus square root again. Okay, green curve easier, it's the circle equation. Okay, hence, let's write in the area. 4 times again. But now you have to be careful on the red color piece. Red color and green color piece will be different limits. Red color piece will go from 2 to 4. If you check the y limits, red color piece 2 to 4. I choose the positive root because it's on the right side. X being the subject, you get right half. So choose the positive root. 4 minus a quarter y squared dy. And you then subtract away from 2 to root 7. Circle equation, again, positive root. But make sure you are careful in this situation. We judge that it's actually different limits altogether. Okay, this question actually they said exact. So if it's actually exact, then no graphing calculator allowed. You just have to read accordingly. But let me skip the integration. It makes use of the part 1 answer from this by parts.